Okay, so for actually, it's going to be the fourth question on discrete random variables. This is a particular type of one that comes up from time to time, not that often, called the discrete uniform distribution. They've been quite helpful describing it as a discrete uniform distribution here because in some ways it should be quite clear from the way it's written. Again, just like the last question, we're not given a table. We are given that the x is equal to 5. Okay, so here it wants us to show that n equals to 9. Now, there is a formula. If you've got a discrete, to find the expectation of a discrete uniform distribution, and this one is particularly easy to remember. Okay, so instead of using the standard formula, which does work, which is that, it does work because it's a discrete random variable. That one might be more useful. For example, what we're saying is, just if we go up in the numbers, that's a discrete uniform distribution. The mean of that is just the average of the 1 and the 2. The expectation, if we had 1, 2, and 3, yeah, if you have the thing of 1, 2, and 3, we'd have a third, and the mean of that would be 1 plus 3 divided by 2, which is 2. So that's quite an easy formula to remember for the expectation. And it's actually comes in particularly useful here because we get our 3 marks very quickly if we do that. It says so that n equals to 9. Well, here, what we can say is, well, we know the first term is 1 and the expectation is 5. So we have 5 is equal to 1 plus n over 2. So we have 10 is equal to 1 plus n equals to 9. Okay, now what a lot of people did in the exam is they drew a table. It was acceptable. They accepted, in this particular term, they accepted the idea of verify. So in other words, if you were, which is what most of the people actually did when they took it, to write out a table with the 1/9 showing, and then use this formula to demonstrate it was true that E was equal, variance is equal to 5, or something like that. It was in the exam considered acceptable. But actually, that's more like verify, where you'll verify the EX is equal to 5 if n is equal to 9, working the other way around. And they allowed that in this particular case. Okay, so that does work. That's our discrete uniform distribution. So now we've got to be careful here because that's asking for probability of x, this is the second part, less than 7. It's got to be 6 or below. It can't be equal to 7, so it's quite common. So in fact that's going to be 6 out of 9. Quite common for, especially in exam conditions, to miss that and actually say 7 out of 9 or something like that, 7 out of 9. Right, now variance of x, 2 possible approaches. One, there is actually a formula for the variance of a discrete uniform distribution which starts at 1, and that is variance of x is equal to n plus 1, n minus 1 divided by 12 for a discrete uniform distribution starting at 1, for this type of distribution starting at 1. The only problem is you're going to have to remember that. So is it worth it? That's a question you have to answer. That's only the question only you could really answer. Is it worth it to remember that for a discrete uniform distribution? It will save a little bit of time because you would have n is that would be 10 times 8 over 12, which is equal to 20 over 3. 6.667, or 6.67 to three significant figures. Okay, but in the absence of that, and I think it's fair to say no one did that because couldn't remember that formula. In the absence of that, we're going to have to use our standard formula, which is the variance of x is equal to sigma p x equals to x of x squared minus mu squared, or if you want to prefer it in the other notation with the expectations, e x squared minus e x all squared. They both mean the same thing, but you're going to use that, which is going to take a little bit longer. It's not terrible, it's going to do us that much harm, but it will take a little bit of time. We're doing 1 squared. I suppose one thing we could do to speed it up a bit is to kind of factorize it. That's all times by 1, because they're all times by 1/9. So the probabilities are all 1/9. So we could just add all the squares and then divide the sum of that by 9, and then take away the expectation squared. So that's this number here. And that should give us, well, I'm sure it will give us, the same answer for the variance 6.67. Right, okay.